Sometimes the octet rule is not followed. There are some exceptions. These include expanded valence, which can occur in periods 3 and above, radicals, where you have an odd number of electrons, and an incomplete octet, where the compound is stable with less than 8 electrons in the valence shell. Let's take a look at the expanded octet example. Let's look at the Lewis dot structure for phosphorus pentachloride. First of all, let's think about the number of bonds that we would predict that would exist in this particular structure using the S equals N minus A rule. Let's look at the S equals N minus A rule for the phosphorus pentachloride. Needed phosphorus, there's one phosphorus, and phosphorus is in group 5. So phosphorus needs 8 valence electrons. There's 5 chlorine atoms. Chlorine needs 8 valence electrons. So that's a total of 5 times 8 is 40 plus 8. 48 needed electrons. Available. Phosphorus is in group 5, so that would be 5 valence electrons. And chlorine is in group 7. So that is 5 times 7 is 35. So that's a total of 40 available. So when we predict the number of electrons that should be shared here, we have 48 minus 40 equals 8, or 4 bonds. But when we look at the structure, there's 5 terminal atoms, so you need at least 5 bonds. Anytime you're working with a central atom that's in period 3 or above, and the S equals N minus A rule predicts that you need fewer bonds than you know need, you know you're dealing with an expanded octet situation. So our central atom is not going to follow the octet rule. So what we do is we just go ahead and put all of our chlorine atoms as terminal atoms. 2, 4, 6, we've used 10 of our available 40, and then place all the remaining electrons that you have around the terminal atom to satisfy the octet of the terminal atom, and you end up using all 5 times 8 is 40, all 40 electrons. So this is the accepted expanded octet Lewis structure for this one. There's a similar case with the sulfur hexafluoride. When you look at the S equals N minus A rule, the needed is going to be a total of 7 atoms needing 8, so that's 54 electrons needed. And you have sulfur is in group 6, and fluorine is in group 7. It's 42. That's 48 and 50 available. And 54 minus 48 equals 6. So it's predicted only 3 bonds, but clearly you have more than 3 bonds. So in this case, again, you just go ahead 1, 2, 3, 4, and place all of your fluorine atoms as terminal atoms to that sulfur, which is big, and it can be an expanded octet. And all of your other electrons will fill out around this fluorines to satisfy the octet of the fluorines. Fluorine is also typically terminal. Halogens are typically terminal when they're found in compounds like this with one central atom and many